Hi everyone, my name is Lebesgue from Barry's Science Lab, and today we're actually going to be looking at a nice measure theory proof. Specifically, we're going to be showing that on R, the Lebesgue measure for an interval is exactly equivalent to our notion of length. In fact, it generalizes length to anything that you can think of. Any set within the real numbers can be shoved in, technically not any set, any Borel sets, but we'll get to that part later. We can shove in any set to the Lebesgue measure, well, most of the time, and it will return a Lebesgue measure somewhere within the positive real numbers. Most of the time it's going to be 0, but in the case of intervals, it's just their length. So what is the Lebesgue measure? Well, it's the infimum of the infinite sum of the lengths of intervals in such that the union of all in's covers, I could have used the superset symbol. The union of all in covers S. Alright. So, let's try that for an interval from A to B. So we're going to show that this is equal to this. So the first step is, well, we have to build it somehow. So the first step is noticing that not only is AB closed, it contains its two limit points, A and B. Well, it contains all of its limit points, but it contains its boundary points. So it's closed, and it's bounded, because we can very easily find C, which is less than A, and D, which is greater than B, and boom, suddenly we found a finite set, or a set of finite length, which is greater than this. Reminder that we already have the notion of length for intervals only. We're simply showing that this is equivalent to length, because this will help us generalize to multiple dimensions. So, AB is closed and bounded. By the Heine-Borel theorem, hence, it's compact, which means that for any open cover, so I'm going to take a bunch of open intervals, in, such that in cover this interval, AB, and for any open cover, we can find a finite subcover. I'll work with it. Okay. So, Jn is just some special, I have an idea. Just write it as IAN. Yeah, that works. So, this finite subcover will also work, right? But it doesn't matter for our purposes, since this cover already has to have a total length, or the sum of its lengths has to be greater than or equal to B minus A. Otherwise, of course, it couldn't cover A to B. So, that means that the Lebesgue measure of AB has to be greater than or equal to B minus A. But we can also say that AB is a subset of A minus epsilon, I don't know if I added this, B plus epsilon, given epsilon is greater than 0. So, notice that this has length B minus A plus 2 epsilon. But we can make epsilon as small as we want without any consequences. And reminder, this is using the length of this in the context of plugging it into this infimum. So the infimum of this set, such that epsilon is some positive real number, is just b minus a. Well, yeah, it's the infimum, not the minimum. Doesn't necessarily have to be in the set. Hence, this is less than or equal to b minus a. Now, of course, why am I saying less than or equal to instead of just equal to? Well, because I don't actually know that this specific sequence, I1 is equal to a minus epsilon b plus epsilon, I2, I3, dot, 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 or empty. I'm not sure that this specific sequence will minimize this infimum. But we already know that the infimum has to be something less than or equal to this. This is like an upper bound for the infimum. So, okay, how can I phrase it? For this particular sequence of intervals, we plugged it into the formula and found that the infimum is equal to b minus a. Now, there might exist some sequence that gives us an infimum less than b minus a, hence the less than part of the less than or equal to sign. But if there isn't, then this is the sequence that minimizes the infimum. Hence, that's the sequence we use, which is why we have the equal sign in there, no greater than. Okay, so the Lebesgue measure is less than or equal to b minus a, but it's also greater than or equal to b minus a, which implies that it has to be equal to b minus a. Hence, it's equivalent to the length for ordinary intervals. That's it. Thank you everybody for watching.
Today was so short.
Well, yeah.